The topic will be law of conservation of momentum and collisions. So I'll start with the law of conservation of momentum. See, try to please understand the law of conservation of momentum deals with the first thing I need to say. Uh, See, you are strictly allowed, particularly to apply law of conservation of momentum and all these things only under certain conditions. What are the conditions? See, there should not be any external force. When, see, what is the law of conservation of momentum? Law of conservation of momentum. So, what exactly this reveals? When no external force acts on the system, comma, dp bar by dt is equal to 0. Means no external force acts on the system. So Newton's second law, you will write it in this form. For example, you are not speaking about a point. Suppose if I am speaking this for a system or system of particles. Now tell me how this will take the form, which means P1 bar plus P2 bar plus P3 bar plus so on. Pn bar remains constant. When there is no external force, the algebraic sum of momentum of the particles of the system remains constant. This is a law of conservation. The compulsory condition is no external force. So when there is a no external force acting on the system, Newton's second law will take the form dp bar by dt is equal to 0. And system of, you can conserve this in any direction. For example, if you want to express this in a two-dimensional sense, suppose, for example, in a one-dimensional sense, 1D case, which means particles, suppose M1 moving with U1, M2 moving with U2, and they will move only in one-dimensional motion. Then you can say that M1 U1 plus M2 U2 is a constant. In a 2D case, in a 2D case, maybe they are moving in different directions, maybe. But what we will do is, in a 2D case, you will say that sigma px is a constant and sigma py is a constant. See, with this vectorial approach, you should take. Like, for example, if both are moving in the same direction, you will take it as positive. One is moving rightwards, the other is moving leftwards. You will take one as positive, the other as negative. Please remember this. The entire chapter, you can apply this condition. Frankly speaking, this entire context, whatever that's there on the board, the entire contest, this entire constant, I will do minimum 20, 30 problems. So I am not discussing anything which is different. I am just mentioning law of conservation of momentum is nothing a different case actually. It is another format of Newton's second law of motion. In fact, working of a rocket also is also on the basis of Newton's second law and the law of conservation of moment. Even working of a rocket, balloon, you blow some air into the balloon and release it. You will see the same situation. Okay, I'll just take some problems on this and we will proceed further. Like we will take the first question. An explosion blows a rocket into two pieces. See that? An explosion blows a rocket into two pieces. One go off at right angles to each other. Right. Now please see 1 kg piece with a velocity of 12 meter per second and 2 kg piece with a velocity of 8 meter per second. And if the third piece flies off with a velocity of 40 meter per, so I am assuming that all the three are in same plane. This is the first observation. Right. So one piece is say moving in this direction and its momentum is 1 into 12. P2 is 2 into 8, 16 kg meter per second. 12 kg meter per second. Right. Now, the momentum must be conserved. Any particle, see, if it has to be a system, isolated system, and according to linear momentum conservation, P3 must be in this direction. According to law of conservation of momentum, you can write it as P1 bar plus P2 bar plus P3 bar is equal to 0. Means P3 bar will have minus P1 bar plus P2 bar, which means direction is opposite to the resultant of these two. So therefore, finally, P3 square can be given as P1 square plus P2 square because the angle is 90 degrees. P1 square, which is 16 square, P2 square, which is 12 square, 4 square plus 3 square, this is a 20 square. Yes or no? So finally, P3 is 20 kg meter per second. Now, but you said that if the third piece flies off with a velocity of 40 meter per second, so P3 is 20 kg meter per second. P3. P3 is nothing but M3 times V3. 40 is equal to 20. So M3 is half kg. Any doubts? Clear? Right. Next. A projectile is launched at an angle of theta naught with velocity v naught at the highest point of its trajectory. Okay, you can see that the highest point of the trajectory it explodes into two parts, masses in the ratio 1:3. We will take up this as vertical and we will take up this as horizontal. Right. Now you have the projectile like this. Right. At the highest point of its path, it explodes into two parts of masses in the ratio 1:3. The higher mass retraces its path. Lighter mass retraces its path. You know what is the meaning of this? Before, no, you said 1:3. I will take this as 4m times u cos theta. Now I'll take up it as three parts. You said the lighter one. To retrace its path, the lighter one, whose mass is m, must possess u cos theta velocity in the reverse direction. Yes or no? Why? Because you said it retraces the path. Whereas the heavier mass, the heavier one, here, the heavier one means whose mass is 3m, will have a velocity Vx. Just before, just after. Linear momentum is conserved. Just before, just after, at the highest point, because collision is a very instantaneous process. You can conserve. Even though there is an external force mg, the change that it would bring in that time is negligible. I know, even though there is an external force mg, the change it would bring in that time of explosion is very, very, very small. So in that situation, just before, just after, you can conserve. Long time before, long time after, you cannot conserve. Right? Now in this case, sigma px is constant. So therefore, 4mu cos theta can be written as minus mu cos theta plus 3m Vx. So with this you can write Vx as, this will become m's you can cancel first of all, and this is 5/3 u cos theta. So applying law of sigma px constant means applying law of conservation of momentum along x-axis at the highest point. Any doubt? Next. Two trucks, each of mass capital M, are moving without friction in opposite direction on adjacent parallel tracks with same velocity u. One is carrying potatoes and other is carrying onions. Right. We will call, okay, leave it. In fact, this problem is there even in Irido also. You have this problem in Irido also. Right. Okay. Now try to see what is happening there. What exactly is happening over there. One is carrying potatoes, other is carrying onions. Bag of potatoes has mass m1 and bag of onions has mass m2. When I am saying m, it is included, which means what is the mass of this empty truck? M minus small m1. What is the mass of this empty truck? M minus m2. When trucks gets close to each other while passing, drivers exchange the bat with the one other by throwing either kamal either exchange. Find the final velocities of the truck after exchange of the bags. So I need to draw the diagram very carefully in this process. Now try to please understand. This is having speed u, whose mass is m minus m2. And this basta is having mass m2, and this is also moving with the speed u. Right. Now similarly, this is having mass m minus m1. U. Any doubts? Right. Now the question is, this is initial system. Now see, now we need to conserve momentum like this. Now you take this as your system. That as your system. Initial system. I will call this as system 2. I will call this one as system 1. Any doubts? Now take system 2 alone. We will take, this is the positive direction. Right hand direction is taken as positive. System 2. System 2, you are having m2u minus m minus m1 times u is equal to, usually truck mass is more. So therefore, m minus m1 plus m2 times v2, and there is a minus sign here. Why minus sign? I'm still assuming the truck is moving leftwards, which means this is the initial system. Final system is m minus m1 plus m2, and this system goes with v2. Finally system 2. Initially system 1. Initially system 2. Any doubts? Now why don't you solve this? Now this will become, that minus give this side. This minus give this side. Minus m2u plus v2 is m minus of System 2. Now you take system 1. Now what is system 1? M minus M2 times U minus M1U is M minus M2 plus M1 times V1. Allowed? Areyar, my intention is very clear. My system thereafter is M minus M2 plus M1. And this moves with V1. Finally, system 1. Any doubts? Finally, you will write V1 as M minus M2 plus M1U divided by that's the deal, V1. Any doubts? It's a very famous model actually, and it is also from Iridu. This is also from Iridu actually. Right? Next question. Shall we proceed for the next question? Right. A railroad car of mass M is at rest on a frictionless track with a it's a very good question actually. A railroad car of mass M is at rest on a frictionless track with a man of mass M standing at its edge. If the man jumps off from the car towards right with an initial velocity u with respect to the car, find the velocity of the car after its jump. Now see, try to please understand the man is standing over here. Right. Remember, this is u with respect to the car. Is jumping out. Initially, the entire system is rest. P initial is 0. Then what happens? P final we will take this direction as positive. Why? Heavier one, obviously. So in air, when he is in air, he is having velocity V2. And this is moving with velocity V1. Right. But no one given you the value of V2. So MV1 is MV2. You know what is V2? V2 refers to velocity of man with respect to ground. Velocity of man with respect to ground is given as velocity of the man with respect to car plus velocity of the car. కరెక్టేనా? కరెక్టేనా కాదా? Yes or no? So now clearly they have given this part as U, and this is V2 actually, and this is V1. So clearly MV1 is equal to MU, 1 minute, just 1 minute. Velocity of 2 with respect to ground Arrear, I've done mistake. Correct. This is V2, U minus V1. Correct. So therefore, from this you can write this one as M plus small m. I am telling you again, you can use the same relation for gun and bullet, or cannon and shell. In case of this V recoil, you will call that as V recoil is equal to small mu by capital M plus small m. In this, U is called muzzle velocity. Everything is the same. In the place of the car moving back, you will call that as recoil velocity, which means when the gun initially you are firing the bullet and that comes out, and this will recoil. Even for this case also you will use the same relation. Cannon and shell also you will use the same. Only difference is cannon and shell only components along x-axis. Yes, you have some doubt, can ask me. No, wait a minute. See, try to please understand. ఇది అయిపోయింది కదా స్కేలార్ సబ్స్టిట్యూషన్. ఇంకెక్కడి నుంచి అన్ని నెంబర్సేగా. దిస్ ఇస్ స్కేలార్ సబ్స్టిట్యూషన్. ఎందుకు వస్తుంది? ఆల్రెడీ ఇక్కడ సబ్స్టిట్యూట్ చేసేసా కదా. అదే కరెక్టేనా? అదే ఇక్కడ సబ్స్టిట్యూట్ చేసేసా కదా నేను. దిస్ ఇస్ ద స్కేలార్ రిలేషన్. సో యాక్చువల్గా ఇది ఏమని రాయాలంటే మీ లాంగ్వేజ్ ప్రకారం చెప్తాను చూడండి. This is the substitution. Varun, finally this will become in this form. Okay na kada? Right. Next. Are we clear on this? This is also a Irido problem. This is also a problem from Irido. Now see next question. Go through the next question. Two identical buggies, each of mass m, moves one after due to inertia. Means by some natural cells they are moving. See, the left hand system is buggy plus a man moving with V0. Right hand system is only buggy moving with speed V0. Right. At a certain moment, the man jumps into the front buggy with a velocity relative to his buggy. Okay. Knowing that the mass of each buggy is equal to m, find the velocity with which the buggies will move after. Now, in this question, so what I am noticing is that a small correction might be required. I'm thinking that u relative to the buggy 1. Say this is 1 and this is 2. That must be mentioned. Right. See, you need to see 3 different snapshots of the situation. There are 3 stages involved. Right. This is the initial stage where the entire system is moving with V naught and this buggy is also moving with V naught. After jumping, the man will have some V dash velocity when he is in air. And thereafter, and this is having velocity V1. Agreed? And thereafter, the man jumps onto this. This one will move with V1, and thereafter, this one will move with V2. That's the picture. Got the point? So therefore, first thing, so we will take this situation separately. This situation separately. Have you identified how I am separating the systems? My entire skill lies in separating the systems here. So therefore, capital M plus small m V naught is the initial momentum of the system. And the remaining is mv1 plus small m v dash. But we don't know what is v dash. V dash is with respect to ground. Velocity of the man in air with respect to the ground. So velocity of the man with respect to ground is velocity of the man with respect to 1 plus velocity of the 1. So I defined this as a V dash. We will take now this direction as positive as a whole. V dash. Velocity of the man with respect to 1 is given as U, and this one now becomes V1. Right. So therefore, if you allow me, I'll write this as capital M plus small m times V naught is mv1 plus m times you want V dash U plus అంతేగా u plus v1 actually v1. So finally you will write v1 as capital M plus small m v naught minus mu. కరెక్టేనా? divided by just please confirm whether my steps were correct or not. Varun, పక్కానా? Let me just confirm this again. Two identical buggies, each of mass m moves one after. Okay, fine. With some velocity. A man of mass m rides the rear buggy at a certain moment. The man jumps into the front buggy with velocity u relative to the buggy. Knowing that the mass of each buggy is equal to capital M, find the velocity with which the buggies will move after that. Right. Next. For the next system, what is your approach? mv0 is the momentum of the system. అంతేగా? కరెక్టేనా నేను చేసేది? రాంగ్. ఎట్లా కరెక్ట్ అవుతుందిరా? అప్పటిదాకా సిస్టంలో క్యాపిటల్ ఎం మాస్ ఉండి ఫైనల్ సిస్టమ్ మాస్ క్యాపిటల్ ఎం ప్లస్ స్మాల్ ఎం ఎట్లా అవుతుంది? రాంగ్. వాడు ఎయిర్లో ఉన్నప్పటి దగ్గర నుంచి లెక్క తీసుకోవాలి. విచ్ మీన్స్ mv0 ప్లస్ mv డాష్ ఈజ్ ఈక్వల్ టు capital M plus small m v2. So here applying law of conservation of momentum for case 1. I am applying law of conservation of momentum for case 2. అందుకే నేను ఇక్కడ ఏం రాశాను, ఇక్కడ వీడిని గాలిలోనే చూపించుకోవాలి. ఇంకా మనం ఆ పార్ట్ ట్రాక్ పార్ట్ కూడా నేను చూపించాను అందుకే మీకు. సో వాట్ ఈస్ ద ఇనీషియల్ సిస్టమ్? మ్యాన్ ఇన్ ఎయిర్ ప్లస్ buggy 2. Final system, man and buggy together moving. So you know what is v dash? U plus v. mv0 plus m u plus v0 u plus v1 is equal to capital M plus small m v2. But you know what is v1 now? You know what is v1 now? Just a substitute here, which means mv0 plus, sorry, u plus v1 now becomes u plus v1 now becomes u plus m plus small m times v0 minus mu by capital M plus small m. So this will be mu, okay, mu plus right. So therefore I can write this as mu plus capital M plus small m v0 by capital M plus small m. This is equal to capital M plus small m v2. Just solve this accordingly. So I have done this. I don't want to proceed further. Only thing that you need to understand is how to apply concept here. That's all. Don't you see that? Here it's a same thing I'm applying for all the 4 problems. Only one single concept is repeatedly applying We are simply applying the same concept repeatedly. Next. Next question. Go through the question. So, this is initial situation and this is the final situation. I need to define V dash. And don't forget, repeatedly I am doing this. Velocity of the man with respect to buggy is velocity of the man minus velocity of the buggy. And you have given this as plus u. I want this as V dash. And this I have written it as V2. Agreed? That's all. That is the crucial part. So therefore, V dash is U plus V2. Apply law of conservation of momentum. So what is the law of conservation of momentum here? Capital M plus small m V1 is equal to capital M V2 plus small m V dash. So capital M plus small m times V1 is MV2 plus V dash is plus V2. So finally, I can write this as V2 is capital M plus small m V1 by capital M plus small m minus small m by capital M plus small m u. Any doubts? Just confirm this. So finally, I can write velocity of the car after jumping is this. What do you want? Velocity of the man, if you want, it is simply V dash is U plus V2. That's all. That you can do. Any doubts in this? You will definitely get questions from this area. Do. A light spring of spring constant K is kept compressed between two blocks, masses small m and capital M on a smooth horizontal surface. When released, the block acquires velocities in opposite direction and the spring loses contact with the blocks when it acquires its natural length. If the spring was initially compressed through a distance x, find the final speeds of the two blocks. You know what is the initial situation? This is the initial situation. Rest, rest, compression in spring is x. Capital M relaxed. Say this is having V2 and this is having V1. Agreed? First thing is law of conservation. There is no external force actually here. Momentum must conserve. So therefore, mv1 is equal to small m v2. Equation 1. One more important point is in C frame of reference, half small m capital M by small m plus capital M, V1 plus V2 is the relative. Do you remember this? Half mu V relative square is totally half kx square. Agreed? So therefore, V1 plus V2 is under root k times capital M plus small m by capital M small m times x. That is V1 plus V2. That's all. V1, you will get a small m by capital M. You just push this in. Finally, you will get k is a common. Small m by capital. And అప్పుడు ఇక్కడ small m అలానే ఉంటుంది. By capital M times capital M plus small m times x. Similarly, V2, copy చేసిండంతే. What is there in that? K by small m times capital M by capital M plus small m times x. Any doubts? So what is the contribution from this chapter? Only one step. And the contribution from last week chapter? This one. Any doubts? Pakka. So till now, I am using only one concept, one step. But remember, in all these cases, there is no external force. Next. Right. Now make it. Try to work on question number 11. All the models, till now I am doing only one simple concept, linear momentum conservation. Right. Two trolleys A and B are free to move on a level frictionless track and are initially stationary. A man on trolley A throws a bag of mass 10 kg with a horizontal velocity of 4 meters per second with respect to himself onto the trolley B of mass 100 kg. The combined mass of trolley A excluding bag and the man is 140. Find the ratio of velocity of the trolley A and B just after the bag lands. Same story. Now you have the situation like this. This is a trolley A. This is a trolley B. Here is a man and here is a luggage. This is the first part. The entire thing Now what is happening? Now he is throwing this one onto this trolley. See, you can take almost horizontal. I don't say like a parabola, it's like almost horizontal. For convenience sake, I am just posting this as some V dash. As a result, this system will have a velocity V1 backwards. Thereafter, thereafter, see the combined mass will now move with velocity V2. We have done already this model. Okay, now first thing that you need to see is what is the system. This is our system. What is the next system? That is the system. ఇందాక అదే కదా మిస్ చేసింది మీరు అంటే గాళ్ళు తీసుకోవాలి కన్సిడర్ చేయాలి రైట్ వాట్ ఈజ్ V1 ఫస్ట్ ఆఫ్ ఆల్ V dash velocity of the bag with respect to system 1 is velocity of the bag minus velocity of the system 1. You said that is U, for example, and velocity of the bag is V dash minus V1 because they are in opposite direction actually. So therefore, I can write V dash as U minus V1. Right. Let this be system 1. So if I apply law of conservation of momentum for system 1, see the masses also. A and B are the combined mass of A excluding the bag. 0 actually, nothing is there for the system. Initially it is 0. Finally it is area 140. Ramesh. Right. Okay. లేదు కంటిన్యూస్ చేసుకుంటూ వెళ్ళిపోయాను అంతే రైట్ this is nothing but minus V1 times 140 plus you remember man on trolley A throws a bag of mass. This is 4 meters per second. U is given as 4 meters per second. So U is given as 4 meters per second. 140 10 times 4 minus V1. So now altogether this is 14 V1 is equal to 40 minus 40 minus 4 minus V1. And then this 10 and this 10 you have cancelled. So therefore 15 V1 is equal to V. So V1 is 4 by 15. Any doubt? None, any doubt in that? Please ask me now. Any calculation mistake or any substitution mistake, just Please bring it to my notice. So V1 is 4 by 15 meter per second. Any doubt till this point now? No. No. Next. Now with this you can calculate V dash also. What is V dash? V dash is 4 minus 4 by అంతే కదా. This is nothing but 15 4 is 60 minus 4, 56 by 15. 56 by 15 meter per second. V dash. Now what is your next system? Next system to law of conservation of linear momentum for system 2. Yeah, you tell me 10 times V dash is equal to 10 plus trolley B is upon 100 kg. 100 times V2. So clearly V2 is 1 by 11 times because 110, 10 cancel. V dash. So, and if it is 56 by 15 times 11 meter per second. Any doubts? Boys and girls, do you really have any doubt? Right. Next. Next. Right. 12th question. Go through 12th question, everyone. I think almost the same question. Identical buggies, but okay, right? No issues. This is also an irido question actually. Everyone, please focus on this. Almost same models I am doing. Maybe tomorrow also I'll discuss the same topic. Okay. Now it is a purely your question. Do it. You should get answer as V1 is equal to mv by capital M minus small m. V2 as this is the one which you should get. Now try this. You have two identical bogies, 1 and 2, with one man in each move along parallel rails. When the bogies are opposite to each other, the men jump in a direction perpendicular to the direction of motion of the bogies, so as to exchange. Same question we have done. Very second question, if I am not mistaken. I'll just show you that. This is the question. There is no difference. There is no difference actually. Right. Now, only thing is some adjustment is required. As a consequence, buggy 1 stops. And buggy 2 keeps moving in the same direction with its final velocity v. That's the data. Hold on. You have two identical buggies with one man in each. Move along the parallel rails. Right. Mass of each buggy without man, capital M. Man mass is small m. Right. Now the same question, which is coming to rest? Buggy 1 comes to rest. Now Now let us try to understand what is our system. Remember, this is buggy 1 and this is buggy 2. And this is moving with velocity v1, m, and man also moving with velocity v1, m, and he is moving with v2, and this is also moving with v2. This is the system initially. What is the final system? The final system is m plus man at rest. And in this m plus man moving with velocity v. What is your system actually? Your system is actually this. And this system is taking a format like this. That is the system initially for the first one. And finally, it is coming to rest. Clearly agreed, right? Okay, for this system, I have applied. Now for this system, that's given. Hello, that's given in the system. Yes or no? Now the question is, I'm eliminating V2 now. How to eliminate V2? Capital M by small m, V1 minus MV1. So this is nothing but m square minus m square, V1 by m is equal to capital M plus small mv. Therefore, V1 is small m by capital M minus small mv. Capital M by small m V1. Obviously, V2 will now become that's the deal. Any doubts? Are we clear? Sure. Very, very good question. But try to see we are applying the same old one equation, law of conservation of linear momentum. Okay, now move on to question number 13. And again, not a big difficult question. A railroad flat car of mass capital M can roll without friction along a straight horizontal track. Initially, a man of mass M is standing on the car, which is moving to the right with speed V naught. What is the change in the velocity of the car if the man runs to the left so that his speed relative to the car is V relative just before he jumps off and hits a left end? Remember, till now, all the jumpings are happening in the right side part. Now the jumping is happening in the left side part. Yes or no? So left side part, we see that there is a jumping. Now, now let us take the situation like this. What is the initial system? That is the situation. Initial situation. Final situation. Okay. Or else, okay, right. We'll write this as instead of V2, right? No issues. Now we need to conserve the momentum. Capital M plus small m V naught is equal to, that is the initial moment. What is the momentum of the system thereafter? MV2 plus small m. Now I am substituting straight away. I have done n number of problems. Actually, you will write, of course, it has minus V1. But what is minus V1? You are already aware of. Here, velocity of the man with respect to trolley is velocity of the man minus velocity of the trolley. You said u relative to the trolley. U, for example. Okay, u relative, actually v relative. No, this time they have given v relative. V man, that is V1. V trolley, which is nothing but V2. So clearly V1 is nothing but, what is that you are getting? V1 or minus V1 is nothing but, you want minus V1 actually. So minus V1 is nothing but V2 minus V relative. Just substitute, you'll get the answer. What is that? That's all. Done. So finally, you will have V2 is V naught plus, అంతేగా ఇది అక్కడ పంపిస్తారు మీరు, MV relative by capital M plus small m. They are not asking V2 in this question. Try to understand. What is that they are asking is the change. So V naught, in fact, what they want is V2 minus V naught. V2 minus V naught is nothing but MV relative by capital M plus small m. So you got what they want. Okay. So the rest of the part we will deal it tomorrow. Time right. Go to your class. I'll complete this.